Welcome to another episode of Chemistry from Jay's House. We're going to do a review today, and we're going to cover a couple concepts. The first concept we are going to cover is mixture versus solution. How are they similar and how are they different? And then we're going to go into solute, solvent, and solution. After that, we're going to talk about what makes things soluble or insoluble. And then finally, we're going to close up with everyone's favorite, unsaturated, saturated, and supersaturated. Okay, so memorize those concepts, because that's what we're doing today. So let's start in with mixtures versus solutions. Again, this is a review. I'm assuming that you already have some experience with this. Mixtures versus solutions. Well, basically, if you put atoms together, if you take two different chemicals and you put them together, there's two possible things that can happen. You can have a chemical reaction, right? Let's move that down a little bit. Let's write that a little bit lower. You can have a chemical reaction. As I like to say, stuff goes boom. And that's when, with a chemical reaction, that's when atoms actually change dance partners. That's when you get things like, you take a bunch of oxygen, you take a bunch of hydrogen, the oxygen's bonded to the oxygen, hydrogen's bonded to the hydrogen, and then you give them enough energy and you entice them correctly, and boom, now the hydrogens and oxygens are holding hands together, and you get water. That is not what we're talking about this unit. So take everything that you know about chemical reactions and don't worry about it, because that's not what we're doing. What we are doing today is solutions and mixtures. So what happens if you put stuff together and it doesn't go boom? If you put stuff together and it doesn't go boom, then you have yourself a beautiful thing called a mixture. Now, a mixture comes in two basic flavors. The first flavor is, it's a mishmash of stuff. That would be things like, if I have a beaker of water, oh, it's wonderful, and it's full of water, and I put a figurine in there. That is called a mixture, and the reason why is because there's some areas, like this area here, where I get all water, and there's some areas where I get toy and water. And if I were to, think about the inside of the toy's head, that would just be toy. So if there's different areas of the mixture that have different properties, such as this is pure water and that's going to be wet toy, then we call it a mixture. But what if it's the same all the way through, or homogeneous? Then it gets the fun name solution. And a solution is when you have it dissolved. So you still have your water, but this time you dissolve your salt, your sugar, your country town lemonade in, and no matter where you scoop, doesn't matter if you scoop from here, 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 or there, you're going to get the exact same experience. You're going to have the exact same salt water or Kool-Aid or whatever it is. So if we were going to look at this as a diagram, we would say chemical reactions are when you go boom. If it doesn't go boom, it's called a mixture. And what if it is homogeneous? So a subset of mixture is solution. So solutions are mixtures, but they are homogeneous. That means that they are the same throughout. No matter where you scoop, you're going to get the same stuff. Mixture is trail mix. Sometimes you luck out and you get a lot of M&Ms in your trail mix grab, and sometimes you grab and it's all terrible walnuts. Up to you, man. So if it's not the same throughout, it's a mixture. If it is the same throughout, it's a type of mixture called solution. So solution is actually a subset of mixture. Okay, so they are both, how they're similar, they are both junk that doesn't go boom. How they're different, that is homogeneous, the same throughout. That has different areas of different concentrations. Okay. So I consider mixture and solution now done. So let's talk about things like solute, solvent, and solution. So I like to talk about this initially with boop, boop, boop. Everyone's favorite, salt. So salt, if you add salt to water, so let's just get a glass of water there. It does not go boom. I know you're surprised that the oceans aren't constantly exploding. It does not go boom. It is a mixture. And in fact, you get salt water. And what salt water is of course your delicious water with the salt evenly distributed throughout, dissolved throughout. In fact, there's no way to not make it evenly dissolved. If it dissolves, you can't just say, you know, I'd like the left side to be saltier than the right side because that's how I roll. That's impossible. So that makes this a solution. And one of these is a solute and one is a solvent. Well, the short answer is, the easy answer is what dissolves into what? And since the salt is going into the water, we call that the solute. And since it's the water that's kind of receiving it, it's the water that's embracing it, if you will, that becomes the solvent. So solute dissolves into a solvent to make a solution. Now that is the intro version, but it doesn't necessarily require this dissolving idea of like a solid going into a liquid. It can actually be any state, such as if we think of, I don't know, air. Air's a thing we breathe. It's all over the world. If it weren't, there wouldn't be people all over the world. So if we think of air, and we think of, everyone loves pie charts, and we think of what air is primarily made out of, well, 80%, that means all this stuff is nitrogen. So every breath you take, 80% is nitrogen. There's a lot of nitrogen in the air. And what do our bodies do with it? Absolutely nothing. You breathe it into your lungs and you breathe it straight out the exact same way it came in. Nothing. And then the rest of the air, and so you're talking, something, we'll say 19%, because that's a convenient number, is oxygen. And then we'll say the rest of this is things like CO2, and you'll have things like argon gas, and you have a lot of hydrogen, blah, 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 all that kind of stuff. So if we look at air, the makeup of air, one of these is a solvent, one of these is a solute, and it's 100% decided by percentage. So since the nitrogen is more, then that is the solvent. That is like the water in the last example. There's a lot more water than salt in salt water. And since the oxygen is much smaller, then this is the solute. And we would say that oxygen's technically dissolved in nitrogen in the air we breathe. It's kind of weird to talk about a gas being dissolved in a gas just because we're not used to saying that. We think of things like Kool-Aid dissolves in water. We think of solids dissolving in liquids, but it actually can be anything. In fact, what do fish breathe? They breathe oxygen dissolved in water. So there you have a gas dissolved in a liquid, and so the gas, since there's a lot less gas, we would say the oxygen is the solute again, and the solvent would be the water, because water is much more wet than it is oxygen rich. Okay, so there it is, solute, solvent, and solution. I consider that done. Moving on to soluble and insoluble. Well, what does in mean? at the front of a word. And in case you don't know, there's a bunch of words that use in, such as inability, incompetent, and being a high school teacher, I definitely hear a lot of things that are inappropriate. So what does in mean? It means not. You could have an ability, you could be competent, you could be appropriate, but as we know, all teenagers are full of inability, incompetence, and inappropriateness. Just kidding. That's the kind of stuff that gets you fired. I was just joking. Okay, so in means not. So if we say that soluble means it's able to dissolve, insoluble means it doesn't dissolve. So in our example at the beginning, salt water is soluble. The toy in water is insoluble. And the way I like to think of soluble is, if we think of the phrase able to be a, I'm running out of colors. Solute, if it is soluble, it is able to be a solute, or soluble. So if it is soluble, it is able to become a solute, and if it is insoluble, it can't. Soluble stuff dissolves, insoluble stuff does not. And this is also another way to remember which is solute and which is solvent. If it's able to dissolve, it is able to be a solute. And so that reminds us that solute goes into it. Right? If you are soluble, then you are a solute, not a solvent. You'll note if it had anything to do with solvent, it would be solvable, which is terrible to say. Okay, so look at that. Soluble and insoluble, done. Now let's talk about saturated, unsaturated, and supersaturated. So thinking about these, what we are assuming is that all of these are soluble. For something to be saturated, supersaturated, or unsaturated, it has to be soluble, right? So we are talking about solutions. So one of the trick questions I love to say is things like, I take a glass of water and I put a pen in there. Is the water pen, cup full of water with a pen in it, saturated, unsaturated, or supersaturated? And the answer is, trick question. It doesn't dissolve. It's not soluble. It is neither. It is none of those. Because in order to be unsaturated, saturated, or supersaturated, you have to use something that's soluble because you have to be able to make a solution. So these are terms, these three terms, unsaturated, supersaturated, and saturated, are terms that we only use with solutions. So you'll see that occasionally I'll throw in there the idea of a mixture that is not a solution being unsaturated, saturated, or supersaturated, and I'm teasing you because that doesn't happen. Okay. Unsaturated. I capitalize the S to make sure that we're keeping the un. Unsaturated simply means can take more. So unsaturated, that would be things like I put a pinch of sugar in my coffee. It would be unsaturated because no matter how much coffee I drink, even if it's a tiny espresso, it can take a lot more than one pinch of sugar. So that would be unsaturated. Or another way I like to think of it is That is the person who is doing the hot dog eating contest right at the beginning. He's at like hot dog 1 or 2. He's very much unsaturated. He can definitely take a lot more. And then we get saturated. And that means full. Under given conditions. That means we haven't messed with it yet. That means you just started throwing stuff in. You kept adding salt, kept adding salt, kept adding salt, kept adding salt. And at some point, the salt won't go in anymore. No amount of stirring. You see this a lot with hot chocolate, right? No amount of stirring will get that last disgusting sludge at the bottom into the hot chocolate. And so when you finish your hot chocolate, there's always a little sludge at the bottom because the hot chocolate is saturated. It is full of hot chocolate mix. It can't take any more. And then, and under given conditions comes into play with this next one, and that is supersaturated. And that means overfilled. And for that to happen, you need 3 things to occur. 1, you have to heat it up. So you have to heat the solvent up. So you'd have to heat the water up. That's the usual one. You'd have to heat the nitrogen up, I guess, if you want to add more oxygen. Whatever you have to do, whatever you're talking about, you have to first heat it up. Then you have to add more solute. So it'd be like add more salt, right? So I assume when you're supersaturating something that you've already saturated it, you've already filled it, and now you want to add more. So when I say add more, it doesn't mean go from very unsaturated as in just a little and then just add a sprinkle more. What I mean here by add more solute is that you have already saturated it. It can't take any more. There's still sludge at the bottom that you can't stir in. But if you heat it up, it can take more. So when I say add more, I mean that means after saturating. At that lower temperature, at the original temperature. And then 3, cool down slowly. Now, once you've added more, that is super unstable. This is filled and stable. So if we go back to hot dog eating, eat 1 hot dog, 2 hot dogs, 5 hot dogs, 10 hot dogs. You're unsaturated. The guy can eat more. Or girl can eat more. Women can also be hot dog eaters. Saturated is, oh, I can't, oh, please no more. Oh, you're completely full. There's nothing you can do. Supersaturated, well, that's that Monty Python, just 1 dinner wafer. Oh, please. That means you actually are going to put more food into your stomach, and that'd be like forcefully feeding someone to the point where their stomach actually burst, right? Supersaturated is beyond saturated. You have more stuff in there than there should be, and it is super unstable. It cannot last long that way, because the second it gets a chance, the solute will pull out of solution and form back into crystals or whatever it was. Okay, now the picture that I like to draw with this is this one. And this is a metaphor, and I know it's a metaphor. It's not accurate science happening right here, but it is a metaphor. And that is, if we think of a cup, right? If it has just a little, so we'll say sand. If it has just a little sand in it, then we would say that it is unsaturated. At that point, the cup can totally take more. I can carry the cup easily without spilling any. It is unsaturated. Saturated is when I have filled it to the brim. There, again, easy to, it is filled all the way to the top, but there's a low chance of spilling as long as I'm somewhat careful. Supersaturated is when you have a heaping amount. And that is when you have put too much. And here, again, it's an unstable situation. Any kind of movement with that cup, some of this is going to spill off and fall out. And what I really like about this metaphor is it reminds you not only amounts, it's unsaturated here, it's unsaturated, 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 unsaturated. Boom! It becomes saturated only at this point. So if I were going to clarify this and make this a little more scientifically accurate, that stuff wouldn't be red. Unsaturated would actually be this entire amount. Any value in here would be unsaturated. Even if I'm just a couple grains lower than filled, even if it was right here, that would still be considered unsaturated because it can still take more. It's only when it's nice and level, as if like baking level, you know, you've like leveled off the brown sugar, like that kind, right there, just at that point, do we switch from unsaturated to saturated, only there. And then once you go more than that, once you start making a mound, again, that is an unstable situation. It has more than it should. It is overfilled and it is supersaturated. So there is the talk, the reminder of all the terms. If it goes boom, it is a chemical reaction and we aren't talking about this unit. If it doesn't go boom, we call it a mixture. No boom. But what if it's a special kind of mixture? And that is one where it's homogeneous or all the way through. That is a subset called a solution. And that means it is homogeneous. So this is like salt water. All of the water is just as salty. And this would be toy in water or trail mix, that sort of thing. And then we talked about solute, solvent, and solution. So salt, which there is less of, is a solute. Plus water, which there is more of, is the solvent. Gives you salt water, which is the solution. Then we talked about soluble and insoluble. And remember, if it's able to be a solute, it is soluble. And if it is not able to be a solute, then we put the negating prefix of in front of it and becomes insoluble. And last but not least, we had every amount from, and I won't, oh, sorry. Let me redraw that so it's a little more clear. We'll say that you're looking at the cup exactly across and you can't even see the opening. That means every amount from just under the top to just above empty is unsaturated. There's some messy handwriting for you. You're welcome. If it is exactly at the top, nice and level, then this one amount right there is called saturated, and any amount less than that, 1 grain of salt less, is still considered unsaturated. So this is a whole family of values. This is a very exact value. And then a smaller family of values is the overfilled supersaturated. There are the 4 concepts that we covered. Good luck.